is power functions and function operations. Okay, your power functions referring to what we've been working with our exponents. Sometimes they're fractions, right? Which would make them radicals. Okay, that's pretty much what we're talking about. The function operations are talking about things such as, let's say I have two functions, f of x and g of x. Okay, we've done a little bit of this before. Okay, so today we are going to take like f of x plus g of x, f of x minus g of x. We'll do f of x times g of x. You'll do f of x divided by g of x. Okay, we will also do another thing we've done. We will do f of g of x. Okay, and like I said, we've done that before. Not with these types of things, but we have done it. Okay, so that's just a small list of the type of things that we're going to be doing with the two different expressions that we have. Okay. Okay, your power function is basically anything in the form of y equals ax to the b power. Okay, so maybe b is a whole number, maybe it's a fraction, maybe it's a negative. Okay, doesn't matter. Okay, but there's going to be some number x and then b. So maybe y equals 3x to the third. Is that a power function? Yes, that's a power function. Y equals negative 6x to the 1/3. Still a power function. Okay, so that's kind of what they're going to look like. You might also have, at times, we might add things onto the end of them. That'll come a little bit later, though. Okay, so if I have two functions, f of x and g of x, and f of x really just stands for what? The function of x. So it's like y. Okay, that's like your y. So let's say f of x equals 2x to the 1/2, and g of x equals negative 6x to the 1/2. Okay. We want to find the sum of the functions and, the difference of the functions and the domains of the sum of the functions. Okay, we'll get to that one in a second, talking about what domains are. So the sum of my functions would just be, it'd be like f of x plus g of x, right? That's the sum. Correct? We agree with that? Okay, well, f of x is 2x to the 1/2. G of x is negative 6x to the 1/2. Okay, so we've really already done these. What do these have in common that we're going to treat as our variable? X to the 1/2. So what do I actually end up getting? Negative 4x to the 1/2. Okay. And then they also want us to find the difference. So I would take 2x to the 1/2 minus negative 6x to the 1/2, which would give me, what kind of 8? Did you say negative? Positive, because it's 2 minus negative, right? Is that what you said? Okay. Okay, so there's our two answers, correct? So I found the sum on the top. I found the difference on the bottom. Now the next part says the domains of the sum and difference. Okay? Domain is your x's. range is your y's. I know we talked about that briefly. Okay, so what we're asking ourselves is, what can x equal? Okay, so what are our options for what x equals? Okay, so can x be negative? We want these all to be real answers. Okay, if x, I'm going to write this over here real quick on the side. Isn't that the same as negative 4 times the square root of x? Can you have a negative under a radical and still be a real number? No. So, x has to be what? Positive. Could it be 0 though? So it just has to be non-negative, right? Okay, so the domain has to be a non-negative. I think there's a dash there. And it has to be a real number, right? So it has to be a non-negative real number. Okay? What about for the difference? Same thing, right? Because the only restriction is that the x is underneath a radical, correct? Okay, so this also has to be a non-negative real number. Your x values is your domain, your y values is your range. I don't think they ever actually ask you for the range here. So like, it's because you really can't do it here. There's only x's here. So we're not working with range. We have in the past. In the past, we've always said that the domain is your x's, your range is your y's. Okay, right now, you're really only just finding your domains, because all we have left in the end is x values. Okay. Now, if that would have happened to be a 1/3, can you have a negative under a cubed root?
Yes.
Yes. So then it would just be all real numbers, right? Because you could have a negative. So just keep that in mind. Even radicals, negatives are not okay, right? Odd radicals, negatives are okay. All right. Taking a look at example 2. We're doing the same type of thing, except now we are multiplying and dividing. Okay, so I have, or they give me f of x. I'm going to do one that's not in your book here, so you can keep that one. F of x is 4x to the 1/3. And g of x is x to the 1/2. We want to find first f of x times g of x. And then second, we're going to find f of x divided by g of x. Okay. So we should just be able to write this out, right? It should look very similar to what we've been doing. So f of x is 4x to the 1/3 times x to the 1/2. Can I combine these two things? Yes, I can, because my bases are the same, aren't they? Okay. Right, I'm just going to have to find a common denominator. My bases are the same, so I add my exponents, right? So you're just going to need a common denominator. Okay, so here, the 4 multiplies by the 1. That's there, that's imaginary. Okay, so 4 times 1 is 4. What's my common denominator going to be? 6. So this is actually going to be 2, 6. And this is going to be 3, 6. So 2 plus 3 is? So I have x to the 5, 6. Okay. Now we got to think about this. Let's find our domain. It's under a radical, correct? Because isn't that the same as 4 times the 6th root of x to the 5th. Isn't that the same thing as that? Okay, so it's under a radical. Is it an odd or an even radical, though? It's even, so can it be negative? No. So what would my range be, or my domain be here? Non-negative real numbers. Okay. Now you do have to be careful here, because what if forget about what we just had. What if that was x to the 4th right here? Could my x be negative then? Why, Brody? Brody says yes. Why? Because if I took a negative number times itself 4 times, it actually ends up being positive, doesn't it? So then it could be negative. Okay, so you're going to have to be very careful, okay, because every little thing in this is going to decide on what you can have. Now, if I took a negative number to the 5th power, it's still going to be negative, right? Okay, so just be careful. So it still has to be non-negative. But if it were like this, it'd be all real numbers. Everybody with me there? Because a negative 4 times is actually just a positive. So is it going to take a little thinking into defining your domain? Unfortunately, yes. Okay. So over here, I have 4x to the 1/3 divided by, what was it, x to the 1/2. Shouldn't be a lot harder, right? The only difference is you're dividing, so you subtract now. So Isaiah, my whole numbers give me what? 4. My common denominator is still 6, right? Okay, so this is 2, 6. This is 3, 6. Okay, so Logan, what do I get when I subtract my x's? I get negative 1, 6. So where does that need to go? On the bottom with us, Devin. So I have 4 divided by x to the 1/6, right? Okay, personally, I like to think of that as a radical because it's easier for me to find the domain. Oops. So I have this, correct? Okay, so now we got to think about our domain. Can it be negative? No. Okay. So, is there any other restrictions or things you have to worry about? Do you need to worry that the x is in the denominator? You do if we were talking negative exponents, right? Okay, or radicals. Okay, but not necessarily with this problem. So here, it just needs to be, your domain would be what? Non-negative real numbers. Again, I'm not going to write it that time. Okay, just be careful again. If there's exponents on here, that could change. Okay. We okay with those? Very similar to what we've been doing. We're just having to set up the addition, subtraction, multiplication, division problems on our own, right? We're still doing the same problems. They're just giving us our problem as f of x and g of x, and you have to set it up and solve it. We also now have to find the domain. Okay, with our composition functions, which would be like f of g of x. Okay, that is telling me if I'm finding this, hey, let's say I have my f of x and I have my g of x, and I want to find f of g of x. Okay, what usually comes after my f and x? So isn't this like one big x right here? Okay, but everywhere I saw an x, I plugged in g of x. Okay, so everywhere I see this, I'm going to plug in the whole g of x function. So for example, if f of x is 3x to the negative first, and g of x is 2x minus 1, everywhere I see x, I actually plug in g of x, correct? So instead of being this, it's going to be 3, but then I come across an x, so I plug in 2x minus 1. Okay, that's my entire x, right? And I still need to the negative first. Okay, so I know that's... Composition functions are a little bit difficult, especially if your eyes are closed. Right, Devin? Okay, stay with us, please. Okay, so, first of all, I have a negative exponent. Okay, so get rid of that, right? So let's get that to the bottom. So I have 3 over 2x minus 1 to the first power, which isn't a big deal. Can I simplify that at all? No. There's nothing you can do with that. Because this is one function, or one number, right? And that's 1 on top. So you are done. Okay. Now our catch is, what is the domain? Okay. Is there any reason why... Now, you got to be careful. Can you have a 0 in the denominator? No. So what number would give us 0? 1/2, right? Because 2 times 1/2 is 1, minus 1 is 0. So this can be all real numbers except positive 1/2, right? Now there are multiple ways to write this. You could write this like that, which just means all real numbers such that x does not equal 1/2. Okay, if you don't want to write it all out in words. Okay, that's up to you though. I don't really care. Okay, it's quite a bit shorter if you can put it in symbols like that. That's called what we call set notation, because this is a set of brackets. So that stands for the real numbers such that x does not equal 1/2. What if I wanted g of f of x? So actually in this case I start with which function? I start with g of x, which is 2x minus 1, correct? So I start going, I get 2, but instead of x, I plug in my f of x. So I plug in that whole thing, right? So I plug in 3x to the negative first, and then I need to finish out my g of x minus 1. So this is a little bit more difficult because I can't quite do the same things that we just did because I have that minus 1 on the back. But can I still write this as 2 over 3x? Yeah, that's okay. And then what? Minus 1. One second, I might have messed that up. Why did anybody catch that? Why did I mess that up? The negative 1 only goes to what? The x. I accidentally put parentheses down here and made it go to both of those. Does that make a big difference? Yeah. Yeah. So it should be this. So then you can take 2 times 3, which is over x minus 1, right? Everybody see where I messed that up? Because that negative 1 did not belong to that 3. But where I put it at showed that it did. What is my domain here? Close. Except what? 0. You can't have 0, right? Because you can't have 6 divided by 0. So it would be your real numbers such that x does not equal 0. Oops. Struggling with my symbols. There we go. Real numbers such that x does not equal 0. Sometimes you see your real numbers written like that as well. Okay. The last example would be, you could have something like this. You could have f of x. Okay, just meaning you're starting with your f of x function, but anywhere you see x, you're plugging in another f of x, right? So my f of x was 3x to the negative first. So I have 3, but instead of x, I have 3x to the negative first. And then all of that, because this was my x, is to the negative first. So now let's simplify first. Okay? Now that negative 1 goes to both the 3 and the x to the negative first, right? So I have 3 times 3 to the negative first, x to the normal first. Okay. Since that is a negative, go ahead and put that where? On the bottom. So you actually have 3 times x over 3, which gives me keep going. I can multiply those, right? So that's 3 over 1. So I get 3x over 3, which is x. Is there any restrictions on this? No, because there's not even a fraction anymore, is there? And there's no radicals. So your answer is all real numbers for your domain. Domain is all real numbers. Kind of. I don't care how you write it. Sure. That's how my college professor always did it. I guess I don't know for sure if you're supposed to have that or not. It's just how my college professor always did it. Okay, so with our multiplication, division, addition, subtraction, same stuff we've been doing. You just have to set it up on your own, and now you have to find the domain. Okay, your compositions, we've done those before, but not quite to this extent. So take your time. Remember, you're plugging things in for x. You're plugging entire functions in for x. Okay, I believe I have this as a 2-day lesson. So I believe we'll have an add-on tomorrow. Let me confirm that first before I tell you for sure. Yes, it is. Okay, so today what I would like you to do is 12 through 27. So today you actually don't have any of the composition problems. You'll have those tomorrow. I do have us down for a quiz, seriously, on Thursday.